Okay, so this problem here is very similar to the last one there. Okay, so it talks about a continuous function. Okay, this is a continuous function. It does not say it is smooth though, okay, or differentiable. So it's not necessarily smooth and differentiable. So we have a point at 1, okay, let's say that's 10, and says we have the interval endpoint is 3, and that's 18. Okay, so this is what does it say here? It says that f of 2 must be in between 10 and 18. So f of 2 must fall in this range. Well, there's 2, and we can easily draw an example where that's true. Okay, so but what we're looking for is possibilities where it's not true. And we can show how that is possibly not true. Okay, because I could draw it like this. Okay, it does not say that anywhere that it's strictly increasing. Okay, if that was the case, then that we would have to say that that A would be true. But this is not necessarily the case. I can draw an example where this is not true. Okay, so this is going to be a no. F is increasing on the interval 1 to 3. Again, nowhere does it say that it must be increasing. It doesn't say anything about that. Okay, so we can say that that is not true. Okay, and again, we can see that that purple line is an example where it wouldn't be true. F of x equals 17. It has at least one solution on the interval 1 to 3. Well, that's true because this is continuous. Okay, so 17 is right about there. Yeah, there it is. Okay, and we cannot draw any graph. There's no way we can, even if I make it spiky and non-differentiable, at some point it's got to cross that line. Okay, so this is true. F of x has at least one solution, and this is IVT. So we have the condition of continuity, and we can apply IVT to this problem. Again, we have to recognize that if we're going to make the statement of IVT, we need to state this condition of continuity. So for C or D, it says f prime equals 8 on this interval. Well, we don't know. Well, let's make that f prime equal to 4. Okay, and we'll say that that's the average slope here. Okay, so that's our average slope of 4. Okay, 8 and 2, that's an average slope of 4. And this relates to MVT, but the problem is this function, it's possible that it is not differentiable, okay, not smooth. So that means then that if it's not smooth, we cannot apply MVT here. So this does not have the condition to apply MVT, and this is what it would relate to, the average slope showing up as a tangent slope somewhere on there. Okay, so it fails because it is relating to MVT, and we don't have the condition for MVT. And the last one here says the area under f of x is greater than 20. What that is relating to is this issue here. This area here is 20. That would be the area of 20. And it's saying that this function must have an area greater than 20. Well, that's not necessarily true. Everything I drew there did have an area greater than 20, but we can easily draw an example where that's not true. Because I could have a graph that is like this. Okay, and the area underneath that blue line is definitely not as much as the area under that green area there. So this is not necessarily true. Okay, now, however, if this was continuous and differentiable and concave down, then we would have to say that that would be true. So that would be, again, it is really important if you can graph these and kind of see and play around with what these look like. Okay, you can look at all the different scenarios that you can be given. Okay, so there it is. The answer for this one would have been C based on IBT.